Hey everybody, this is 8.1. Today we're going to be talking about exponents and their rules, and also the rules for logarithms. So they're very closely related. On your notes, you might have an 8.1, and that's the stuff that's up here. I kind of want to make a change with that, so we're going to start with 8.2. We're going to do part of that. On your homework, it will be called 8.1. So basically the first part of 8.2 is 8.1, okay? So first off, before we get into this page, we're going to go and review a little bit with exponents and their rules, okay? So these are not filled in on your notes. There's some examples in green that are on the left side. I'd encourage you to maybe pause and copy those down and see what you remember about the rules for exponents, okay? All right, so first off, if we have an exponent of 0, what does that do? Again, an exponent tells us how many times we multiply, and if we have an exponent of 0, that's like saying that we're not multiplying any 5s or any x's. But there always is a coefficient out in front. So whatever the coefficient is, that's what we end up getting for our answer, okay? So for both of these, your answer would be 1, okay? So anything to the 0 is just the coefficient, all right? Okay, so let's maybe write that down over here. So a to the 0, that could be anything, is always equal to 1. Another one of our things, this isn't really like one of your rules, but 2 to the 1, that's just 2, or x to the 1 is just x. So that's something helpful when we get to logs, that if you have an exponent of 1, it's the same answer, okay? So it hasn't changed. So a to the 1 would just be a. All right, these are probably the ones that are probably more important, so and especially when we're like comparing those with the rules for logs, we're going to find some sort of relationships here, okay? So when we multiply variables, just remember that we multiply the coefficients normally, like 2 times 3 would give us 6. And then when we multiply variables, what do we do with their exponents? So if you ever forget, we could always expand. So x squared is just x times x. And then x times x times x times x 4 times would give us a total of x to the 6th. Okay, so the rule here is when we multiply like bases, they have to be the same base, we can add their exponents. So b to the m plus n. Okay, if we do the second example, maybe give that a try. 4 times 2 is 8. And then don't forget that there's always an exponent. If you don't see it, it's got to be a 1. So we have 1 plus 2 is x to the 3. All right, here is, maybe let's go down to the last one. When we divide variables, what do we do? So coefficients, again, we do the same thing that they normally would. 2 divide 4 is 1 over 2. And then if we look at the variables, again, we can always expand. This would be x 4 times and x 1 time on the bottom. So that could cancel. And we would end up getting x to the 3rd. Okay? And we wouldn't need to have that 1 on top. It would just be x to the 3rd over 2. Why don't you pause and try that other example? So this would be 2. And then, again, when we are, again, this is our rule. Maybe we didn't write that down yet. B to the m minus n. So when we divide variables, we can subtract their exponents. So here, if we're doing this example, we would do x to the 2 minus a negative 2. So subtracting a negative will give us a plus, so we would end up getting 2x to the 4th. Okay, our last rule is it's called a power on a power, or an exponent on an exponent. So if we have an exponent on an exponent, I think the easiest way to do this is just to expand it, write it for this example twice, because we have an exponent of 2, and then we can just use the multiplication rule, so, or the product rule. So 3 times 3 is 9, and here we would add, so x to the 8th. For our next example, x to the 0, again, that is just 1, so 2 times 1 would just be 2 to the 4th, or 2 times 2 times 2 times 2. I think that gives you 16. Okay. And the rule here that we maybe could learn here, I think it's better just to expand, but if you were to write down the rule, then it would be b to the m times n. So if you look, 4 times 2 is 8, and 0 times 4 is 0, so we wouldn't have that. Okay, but I would just expand if you ever needed to use that rule. Okay, all right, so now we did a quick review of that. If you look at the first, I guess there's maybe one more thing we should talk about is negative exponents. So if you have something like x to the negative a, we've kind of talked about this in the past, that if you have a negative exponent, its equivalent answer would be its reciprocal, so like 1 over x, and it keeps the same value, so it would still be a. Okay, and we've had lots of examples where we had like 2 to the negative 2, where we'd say, oh, 2 squared is 4, but the negative will do its reciprocal, so 1 over 4. So it's kind of the same, it's just using with variables. You could also have something where you have a negative exponent in the denominator, and we can do the same thing. We could do it as if it didn't. It would just be x to the a, but we would need to do its reciprocal, move it to the top. Okay, so those are kind of like the two kind of rules about negative exponents. All right, anyways, so that's a quick refresher. That's like the first part of your homework. The next has to do with the properties of logarithms. So like the rules, similar to the rules of exponents, okay? So just to kind of save a little bit of time on the video here, I already have these tables filled in, and I want you to pause and see if you can find a relationship. So noticing that these are in pairs, they have the same answers. Sorry, I did not write that correctly though. That looks like it should be a 9, okay? I want you to look and see how are they related. How are these two related? How are these two related? Okay, so that we can come up with a pattern for the right side. Okay, so hopefully you paused and gave this a try. If we look at this first pair, how does 3 and 4 give us 12? How does 3 and 3 give you 9? How does 6 and 3 give us 18? So the relationship here is if you are adding logs, it's the same as writing it as log of x and y. Sorry, I probably should say that a little bit better. Log of x plus log of y, we can just multiply those arguments, okay? So x times y. Just like this example, 3 times 4 is 12, or 3 times 3 is 9, 6 times 3 is 18. Okay, so this just makes it so that we can simplify, and it will help a lot when we are solving logs. Okay. All right, so here, pause and give this a try. How could you find a value for log of 30 if the 3 button is missing on our calculator? So again, we can use this pattern, this thing that we came up above. It just needs to multiply to 30. So we could do log of 5 plus log of 6. That should give us log of 30. Okay? And if you wanted to check this, maybe we should pause and go to this really quick. If you go back to 8.1 notes, let's talk about this really quick. So how to evaluate. This is a way you could actually actually I should have done this early because, well, I guess I already had the table filled in. But anyways, in class we talked about how to evaluate on our calculator. So if you look at your calculator, as long as it's a scientific, you should always be able to find the log button and the natural log button. Give me 1 sec, I'm going to copy something really quick because this will be helpful. Actually, I guess we could just look at it here. We'll just look at it here, okay? So I feel like the easiest is if you have if you're in class, you're welcome to use one of my blue calculators. It, I think, is probably the easiest, but you can also do all of these with a TI and graphing Casio or something like that, okay? So just look on your calculator, see if you can find the log button, and so we would just type log 100, and you should get 2. So maybe try a couple of these and make sure that you can do it. We'll really need this a lot when we get to the solving, but it's helpful in the meantime. There will be a couple of these on your homework. So anyways, comment if you have any questions on how to find these buttons. Natural log button, again, that's an LN. It should be right by the log button. One thing that it's kind of hard to find is this E. Depending on your calculator, it depends on where it's at. So you could probably just keep looking. There should be a little E somewhere. If you have questions on that, let me know. And then the one thing that you might not be able to find super easy is if you have a log that's not a base 10 or base E. So for example, log base 3. So there should be a button, if you're using one of my calculators, it should be like near the top right. If you have a TI, then you would go to math and go up a couple times to see log base. If you have a Casio graphing calculator, then you would push math, that's F4, and then push F2, which is log AB. Okay, so again, you won't need that super much on your homework. There's just a couple problems at the end, but come and get some help if you have any questions on how to find that on your calculator. Okay, so let's go back real quick. I guess the whole reason I had that here is so that you could type these in and show that those are equal. But okay, all right, looking at the next one, I want you to kind of do the same thing. It's very similar. These first two pairs give you the same answer, the next two pairs gives you the same answer, and the next pair gives you the same answer. What's the relationship between them? How is 10 and 2, how can that give you 5? How can 28 and 4 give you 7? And how can 3 and 4 give you 12? Okay, so hopefully, if you spend a little bit, you probably figure it out. When we divide logs, we can divide their exponents. So the log of x minus log of y, that is log of x over y. Again, for the same reason, this will help us to simplify when we're solving. Okay, why don't you pause and see for number 6 and see if you can come up with an equivalent problem that would not use a 3 on your calculator. So here you could do something like log, again, it's something you divide. Something divides something gives you 30, okay? So, and you can't use 3, so you could do like 60, and what would we have to divide that by? We'd have to divide it by 2, so that would give us log of 30. All right. There's one other little thing down here at the bottom. It says a student noticed that log of 1/2 gives the same result as negative log of 2. How is this possible? So it has everything to do with the same pattern that we came up with. this is dividing, it's just kind of going the opposite direction. We can write it as subtraction. So this is the same as log 1 minus log 2. And if you remember, this is a log base 10. So if you say 10 to what power gives you 1, that would be 0. So that would be gone, and we would only get that negative log of 2. Okay? All right, last off, this is the last rule. Okay? Look at these, they're already filled in. This one's a little harder to kind of like wrap your head around it, so that's why I have this already on the right side. So there's two ways to simplify this. You can either add those, so just like if you do x plus x, that gives you 2x. If we do log 5 plus log 5, that's 2 log 5. So that's what we have over here. We could also use the rule that we used up here, that when we add logs, we multiply their exponent, or their arguments. So that's what's over here. We multiplied what was in those logs, and we can rewrite that as 5 to the 2. So now we have two equivalent results. We can set them equal to each other, and that gives us our final pattern or rule. So y log of x is the same as log x to the y. Okay, so these two are equal. And if you're not sure, you could put it into your calculator and verify it. Okay, so let's go and fill in the log rules over here. So just like with exponents, there are similar rules because logs and exponents or exponential functions are their opposites. So they are very related, okay? So if we have a to the 0 is 1, what is its like similar rule? So b to what power is 1? That would end up giving us a 0. Okay, so it's kind of like those are swapped. If you were to solve this, it would switch it into exponential equation. Okay, same thing here. Log base b of b, those are opposites, and all that's left would be the exponent. So you'd end up just getting 1. Okay, just like a to the 1 is a, log base b of b is 1. Okay, when we did the product rule, when we multiply, we add. With the product rule for logs, when we add logs, we multiply their arguments. So they're like opposite. Okay, so log of b and then m times n. Okay. So kind of see that we have multiply on the left for exponents, multiply, then add. Here we add, and then we multiply. So they're like opposite. Okay. All right, let's go down to division. So when we divided exponents, we subtract, but when we do logs, when we subtract, we divide. So those, again, kind of like swap. So we'd get log of b of m over n. And it has to be in that order. So the negative one, the negative log, if you think of that as like a negative log, that should be in the denominator. Okay, and then our last one, with the last rule that we learned here, is that if we have a coefficient, it's equivalent to having it as the exponent. Okay, so log base b of m to the n. Okay, so let that soak in for a little bit. The first part on when you get to logs is going to be kind of matching. So you're going to be matching these things for exponents rules and for the log rules. Okay. All right, to finish it up, we are going to be talking about condensing. So like we said, we can use these rules to simplify and solve. So the first thing you always are going to want to check for is the power rule. We're going to always want to get rid of all the coefficients and move them as exponents. So the first 4 examples don't have that, so we'll get to that in a little bit. After you take care of the coefficients, then it's always checking or using the other rules when you add, you multiply, or when we subtract, we divide, okay? So for this example, these are all adding, so that means that we're going to multiply all of those arguments, okay? So we'll have log, and then 4 times x times y, okay? So every time you have a positive log, you're going to have it as the numerator. Okay, here's another example. Well, I guess these are all subtracting. Okay, so they all have the same base, log 4. That's the thing that you have to have, is it has to be the same log base. Just kind of like x times y, you can't combine those. Okay, so here we're subtracting, so that means we would divide. So we would have log base 4 of 32 over 2, and then we'd want to simplify that. So log base 4 of 16. And you do not need to, I don't want you to simplify further than that. I just want you to get it to a single log form. So a single, as it says up here, a single logarithm. Okay, again, this would be dividing. So natural log of 28 over 7. And that simplifies to natural log of 4. And then our last one here, sorry, I should probably mix this up so we have another adding, but we would have a over b. Again, sorry, my a's look like 9s. Okay. All right, and then please pay attention for this last part. This kind of takes in all of it. So we have some coefficients, which means that we can rewrite those as exponents inside the log. So this would be a 4, this would become a 2, x to the 2, and this would be w to the 5th, okay? So I'm just going to rewrite that. So log y to the 4th, and then log x to the 2, plus log w to the 5, okay? Usually we don't have parentheses, but if you do have parentheses, you got to either distribute the negative or you got to simplify what's in the parenthesis. So here we're adding logs, so that means we can multiply. So we'd get x squared w to the 5th. And then when we're subtracting, we can divide. So we would get log y to the 4th over x squared w to the 5th. And that would be our final answer. Okay. Let's do this other one. Again, when we multiply, there's no coefficients, so we don't have any exponents. So sorry, there's only one example that had that. So we would have log AB, and then when we subtract, we end up dividing. So we could put a C on bottom. Okay, I'm going to do one more example, kind of crazy one. We're going to do log of, let's say, y, and then minus log of x 2 plus log base z. We'll put a 2 out in front. Okay, so my z's look like 2's. Okay, so again, any log that's positive is going to become a numerator. Any negative log will become a denominator. If we have a coefficient, that's going to become an exponent. So do that first, do the exponent first, and then we can just write down our final answer. All the positives will be on top. So that's a z. And our negatives would be on bottom. That's a 2. Gosh. Oh, heavens. Okay. Well, if you have any questions, please come in. I think that pretty much covers it. We will spend the rest of this, this would be 8.2, next time, and we'll probably spend a little bit more time with using our calculators and talk about the change of base formula. Okay? So again, come in if you have any questions, and we will see you later.